Hi my dear friends, welcome to Venus Ncert. You are in class 10, right? My name is Veena. I am here to teach you mathematics. And the very first chapter of our mathematics textbook is real numbers. It's a very simple chapter. All the chapters of class 10 mathematics is very simple. They are very simple and it's easy to score full marks. That is 100 on 100, right? So, shall we start real numbers? It's so simple, very easy chapter. See, in our lower classes we studied what is real number, what is whole number, what is natural number, what is rational number and what is irrational number, right? So what is the difference among them? Real numbers, it ranges from, yes, you are right, it ranges from minus infinity to plus infinity, right? Minus infinity to plus infinity. For example, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, etc. This is a set of real numbers, right? It can be negative integers, it can be positive integers, it can be 0 as well, right? Now next, what is whole number? Whole number, it ranges from, yes, 0 to infinity. From 0 to infinity, it is whole number. For example, 0, 1, 2, 3. This is an example of a whole number. And what about natural numbers? It starts from 1. 1 to infinity, it is natural numbers. 1, 2, 3, 4, etc. Right? Don't get confused with whole numbers and natural numbers. Natural numbers starts from 1 to infinity and whole numbers from 0 to infinity. Real numbers from minus infinity to plus infinity. And what about rational numbers? Yes, any number of the p by q form where q not equal to 0 is an example of a rational number. Example 3 by 2, 5 by 2, etc. examples of rational numbers. And what about irrational numbers? Root 2, root 3, root 7, root 5, etc. are examples of irrational numbers. So the concept of these 5 terms we know from our lower classes. And in this chapter we are going to explore real numbers, the positive integers. We are considering only the positive integers of real numbers. So we can start the session. In this chapter we are exploring the very two important properties of positive integers. And those two properties are Euclid's division algorithm and fundamental theorem of arithmetic. Okay, what are the properties? Euclid's division algorithm and fundamental theorem of arithmetic. So in real numbers, in this chapter we are discussing two topics, that is Euclid's division algorithm and the fundamental theorem of arithmetic. Now what is the difference between them? See, Euclid's division algorithm deals with the divisibility of integers. So when it deals with divisibility of integers, then it is Euclid's division algorithm. Divisibility of integers means that is any positive integer a can be divided by another positive integer b in such a way that it leaves remainder r, that r is smaller than b. Remember, we will discuss it in detail, but just remember r is always less than b, where b is some positive integer b. How this b comes? This a is divided by this b. Okay, so remember this term, we will discuss in detail. So this Euclid's division algorithm, it deals with the divisibility of integers. That means any positive integer a can be divided by another positive integer b in such a way that it leaves a remainder r, and that r is always less than b. Understood? While in case of fundamental theorem of arithmetic, it deals with multiplication of positive integers. So when it comes to divisibility, it is Euclid's division algorithm, and when it comes to fundamental theorem of arithmetic, it deals with the multiplication of positive integers. Here it is divisibility, here it is multiplication. So understood the difference? So two important properties are discussing in this chapter, real numbers, Euclid's division algorithm and the fundamental theorem of arithmetic. In case of Euclid's division algorithm, that means divisibility of integers. That is, any positive integer a can be divided by another positive integer b in such a way that it leaves a remainder r, and that r is always less than b. Okay. While in case of fundamental theorem of arithmetic, it deals with multiplication of positive integers. Now, where we are using this Euclid's division algorithm and fundamental theorem of arithmetic, Euclid's division algorithm is mainly used to compute or calculate the HCF. HCF, we know, it is highest common factor. We studied in our lower classes, right? So, in order to find the HCF of two positive integers, we are using Euclid's division algorithm, right? But in case of fundamental theorem of arithmetic, we are using it for two applications. First, to prove the irrationality of numbers, like irrational numbers we know root 2, root 3, root 5, and in order to prove their irrationality we are using this theorem. And second application of this theorem is that to explore when exactly the decimal expansion of a rational number. We know rational number, it is of the p by q form where q not equal to 0. So when the decimal expansion of a rational number is terminating and when the decimal expansion of a rational number is non-terminating repeating. So remember these two words, terminating and non-terminating repeating, we will discuss in detail in this chapter. Okay, so you just remember three things. First, r is less than b, second terminating word, and third is non-terminating repeating word. So what is the difference between fundamental theorem of arithmetic and Euclid's division algorithm? Fundamental theorem of arithmetic deals with multiplication of two positive integers, right? While in case of Euclid's division algorithm, it deals with division, divisibility of positive integers. That is, any positive integer a can be divided by another positive integer b in such a way that it leaves a remainder r, and that r is always less than b. And now this Euclid's division algorithm, where it is using this Euclid's division algorithm, we are mainly using it to calculate or to find the HCF of two positive integers. In order to find the HCF of two positive integers, we are using Euclid's division algorithm. And in case of fundamental theorem of arithmetic, its application, it is of two types. First application of fundamental theorem of arithmetic is that we know it deals with irrational and rational numbers. In case of irrational numbers, in order to prove their irrationality, we are using this fundamental theorem of arithmetic. And second case, in case of rational numbers, when exactly the decimal expansion of a rational number is terminating and when it is non-terminating repeating. Understood? That simply we can say that in order to find when this rational number, whenever it is terminating and whenever it is non-terminating repeating. In case of rational numbers and in case of irrational numbers, we have to prove their irrationality. So for these two cases, we are using fundamental theorem of arithmetic. It's easy to remember because Euclid's division algorithm, from the word itself, it is division, so deals with divisibility, and it is used to compute the HCF. In order to find HCF, we are using which method? Euclid's division algorithm. In order to prove the irrationality of number root 5 or root 7, we are using fundamental theorem of arithmetic. In order to prove or in order to find when the decimal expansion of a rational number is non-terminating repeating, we are using fundamental theorem of arithmetic. So this is used to compute HCF, and fundamental theorem of arithmetic is used to prove irrationality as well as to find when the decimal expansion of a rational number is terminating and when it is non-terminating repeating. So remember, r is less than b and the words terminating and non-terminating repeating. So understood? So take these notes. Understood? Euclid's division algorithm and fundamental theorem of arithmetic. It's very easy. Okay. Shall we go to the next one? Understood the difference? Euclid's division algorithm and fundamental theorem of arithmetic, right? Okay friends, so far we discussed what is real number, what is natural number, what is whole number, what is rational number, and what is irrational number. Then here we are dealing with real numbers, considering only the positive integers. And we know that the two very important properties of positive integers are Euclid's division algorithm and the fundamental theorem of arithmetic, right? And Euclid's division algorithm deals with the divisibility of integers, right? Division, divisibility. While in case of fundamental theorem of arithmetic, it deals with multiplication of integers. And when we are using Euclid's division algorithm, we are using Euclid's division algorithm to find the HCF of two positive integers, right? We discussed, right? And what about the fundamental theorem of arithmetic? It is used to find when exactly the decimal expansion of a rational number p by q where q not equal to 0. When exactly the decimal expansion of a rational number is terminating and when it is non-terminating repeating. So in order to find out that, we are using fundamental theorem of arithmetic. Now first we are considering Euclid's division algorithm. Okay, we can go to Euclid's division algorithm. Before that, we have to understand what is Euclid's division lemma. Okay, lemma and algorithm, the difference is that lemma means it is a proven statement used for proving another statement. In order to prove another statement, we are using a proven statement, and that proven statement is called lemma. Understood? Lemma means it is a proven statement used for proving another statement. While algorithm It is a series of well-defined steps which gives a procedure for solving a type of problem, right? In order to solve a problem, we are using a procedure, right? And in order to get that procedure, we use a well-defined steps. And that is called algorithm. Algorithm means a number of steps are involving, but in case of lemma, it is a proven statement. This definition is exactly given in our textbook. So go through that. Once again, lemma, it means it is a proven statement used for proving another statement. And algorithm means it is a series of well-defined steps which gives a procedure for solving a type of problem. This is for your understanding. It is not in the exam point of view. I just give you in order to understand the difference between lemma and algorithm. Okay. So first we are considering Euclid's division lemma. Then we can go to our main point, that is Euclid's division algorithm. Friends, in order to understand what is Euclid's division lemma, we can consider a set of positive integers, right? There are three set of positive integers. We can consider the first one in order to understand what is Euclid's division lemma. First one is 17,6. How we can write 17,6? 17. A is equal to 17 and B is equal to 6. How we can write 17 is equal to 6 into 2, right? Plus 6 into 2, it is 12. And 12 plus dash is equal to 17. 12 plus 5 is equal to 17, right? So we can write 17 as 6 into 2 plus 5. That means 6 goes into 17 twice and leaves remainder 5. This equation means 6 goes into, this is not clear. That means 6 goes into 17 twice, right? 2 times 6 goes into 17, right? 6 goes into 17 twice and leaves remainder. What is the remainder? And leaves remainder 5, right? Yeah. And leaves remainder 5. Understood? So 17 is equal to 6 into 2 plus 5, right? This means 6 goes into 17 twice and leaves remainder 5. That means this is the quotient Q and this is the remainder R. And here it is A and this is B. Understood? So 17,6 can be written as 17. The largest number is equal to 6 into 2 plus 5. Understood? Now we can consider the next one. 512. 512. We can write 5 is equal to 12 into 0 plus 5. Can we write like this? Because 12 into 0, it is 0, right? Plus 5. 0 plus 5 is equal to 5. That is LHS, right? So, here what it means? 12 goes into 5 0 times, right? 12 goes into 5 0 times and leaves remainder 5, right? And leaves remainder 5. And friends, why don't we write like this? 12 is equal to 5 into 0 plus 5. The answer is not same. No, 5 into 0, it is 0 plus 12. Why we don't write like this instead of this? Because I told you in the earlier section that R is always less than B, right? And here R is 12 and B is 5. Is R less than B? Is 12 less than 5? No, 12 is greater than 5. And that is not possible because R should be less than B. So, we have to write like this. It should satisfy the condition R less than B. Here, R is 5, right? This is quotient and this is A and this is B. So, here R is 5, right? And 5 is less than 12, right? So, that's why we have written like that. Understood? So, 12 can be written like this. 5 is equal to 12 into 0 plus 5, which should satisfy R less than B. Here also R is less than B, 5. It is less than 6. That's why we have written like that, right? So, understood? This equation 5 is equal to 12 into 0 plus 5. That means 12 goes into 5 0 times and leaves remainder 5. The next one, 24. How we can write? 20 is equal to 4 into 5 itself is 20. Then plus 0. That means the remainder is 0. 0 is the remainder, 5 is the quotient and this is B and this is A. Here is R less than B. R is 0 and it is less than BS. Understood? So how we wrote 20 and 4? 20 is equal to 4 into 5 itself is 20. Then we should have a remainder, right? So here the remainder is 0. And note that Q and R can be 0 also. Okay? Here Q is 0 and in this case R is 0. So Q and R can be 0 also in some cases. So understood these three problems. Now we can define what is Euclid's division lemma. That means for some positive integers A and B, we have found whole numbers Q and R satisfying the relation A is equal to BQ plus R for 0 less than or equal to R less than B. Understood? R should be greater than or equal to 0, but it should be less than B. So what is Euclid's division lemma? There are some positive integers A and B, and for that positive integers A and B, we have found whole numbers. What are the whole numbers? Q and R, right? Quotient and remainder. We have found whole numbers satisfying the relation A is equal to BQ plus R for 0 less than or equal to R less than B. Now we can define it. In our textbook, you have found that there are so many theorems, right? And this is the very first theorem in our textbook, that is Euclid's division lemma. And you have to study these theorems as it is written in our textbook. You have no right to change that definition. So, write exactly like that in your exam. What it is given in the textbook, write as it is, instead of changing as per your views, okay? So, that's theorem. It is well defined in our textbook. So this is the very first theorem, that is Euclid's division lemma. Please write in this to your book. And it is given that, what does this theorem says? Given positive integers A and B, there exist unique integers Q and R satisfying A is equal to BQ plus R for 0 less than or equal to R less than B, right? We just said now, right? So what is Euclid's division lemma? Given positive integers A and B, right? Then there exist unique integers Q and R. Given positive integers A and B, there exist unique integers Q and R satisfying A is equal to BQ plus R for 0 less than or equal to R less than B. You studied, right? Simple. What is Euclid's division lemma? This is our very first theorem. So what is Euclid's division lemma? Given positive integers A and B, there exist unique integers Q and R satisfying A is equal to BQ plus R for 0 less than or equal to R less than B. Right? Understood? Got it? Okay. Now we can do some more examples regarding this Euclid's division lemma, and then we can go to Euclid's division algorithm. Friends, find integers Q and R for the following pairs of positive integers A and B. That means these are the positive integers A and B. 10, 3. This is A. We have to find out which one is A and which one is B. So usually we take the largest number as A. So here A is 90 and B is 4. In this case, the largest number 81, A, and this is B, right? Now we can solve the first one, 10, 3, right? So how we can write? 10 is equal to, A is equal to, we have to write in the form BQ plus R, right? So we can write 3 into, that is B into 3. 3 into 3, it is 9. Then plus dash is equal to 10. It is 1, right? How we got 1? 10 minus 9, it is 1, right? So 10 is equal to 3 into 3 plus 1. So this is of the form BQ plus R. Is R less than B? Here R is 1 and B is 3. Yes, 1 is less than 3. The condition satisfied, right? So we can write 10 is equal to 3 into 3 plus 1. That means 3 goes into, this 3 goes into 10. How many times? 3 times, right? 3 goes into 10 3 times and leaves remainder. What is the remainder? And leaves remainder 1. Understood? Now we can solve the second question. That is 490. Here A is 19. So we can write 19 is equal to 4 into 5, it is 20, and that is greater than this one. The number should be less than or equal to A, right? So 4 into 4, it is 16. We can't write 5. Why? Because 5 into 4, it is 20, and that 20 is greater than this one. So it is not possible. We have to find a number which should be less than or equal to A. So here 4 into 4 it is 16. 16 plus dash it is 19. How we can find out 19? This 19 minus 16. 3, right? So we can write 4 into 4 plus 3. That is 16 plus 3 it is 19. Here A is 19. 4 is B. Here quotient is 4 and remainder is 3. That means how we can write? 4. Which 4? This 4. B. 4 goes into, that means B goes into A. 4 goes into 19. B goes into A. How many times? 4 times, right? 4 times and leaves remainder. What is the remainder here? And leaves remainder 3, right? Yes, and leaves remainder 3. Understood? Simple. See how simple it is. And the third one, it is 81 3. So 81 is equal to 3 into B is 3, right? So 3 into 27 it is 81. We can check it. 27 into 3. 7 3s are 21. Remainder 2. 3 2s are 6. Plus that remainder 6 plus 2 it is 8 81. That means we can write 3 into 27 itself is 81. Then what is the remainder? 0. Understood? So 81 A is equal to BQ plus R. So how we can write? This B, that is 3, goes into 81 how many times? 27 times. 27 times and leaves no remainder, or we can write and leaves remainder 0. Understood? So if the in the exam, if the question will be like this, find integers Q and R for the following pair of positive integers A and B, you can solve like this, right? This is very simple. 10 3. So first tip is that you have to take A as the largest number. In usual cases we are taking A as the larger number and then BQ plus R. It should be of the form A is equal to BQ plus R and always R should be less than B. The condition should be satisfied. 0 less than or equal to R less than B means R should be greater than or equal to 0, but it should always be less than B. Understood? So far we discussed about Euclid's division lemma. Now we can go to Euclid's division algorithm. Before going to that algorithm, we can just define what does this Euclid's division algorithm mean. Okay? Euclid's division algorithm, it is actually a method to find the HCF of two given positive integers. That is, it is a technique to compute the HCF of two given positive integers. And we know that HCF stands for, it is highest common factor. And we know HCF is also called the GCD. We studied in our lower classes. HCF is also called the GCD. GCD means greatest common divisor, right? So in the exam, sometimes it may ask instead of HCF, find the GCD of. GCD means HCF. Okay, don't forget that. Now we know how to find the HCF of two given numbers, two given positive numbers or integers. How to find HCF of two given numbers is the largest. For example, A and B are the numbers. Then the HCF of two positive integers A and B is the largest positive integer D that divides both A and B. That D should divide both A and B. Understood? So HCF of two given positive integers A and B is the largest integer D that should divide both A and B. So the Euclid's division algorithm is actually a method to find the HCF of two given positive integers, and we know how to find the HCF of two positive integers. How to find the HCF of two given positive integers A and B is the largest positive integer D that divides both A and B, right? For example, we have to find the HCF of 4, 55 and 42. In the normal method, in our lower classes, we studied how to solve or how to find the HCF of these two numbers. How to find, for example, using 7, okay? 7, it is 7 6 are 42 and it is 35. So 7 5s are 35. 6. That means this 7 here, D is 7. This D divides both A and B. Understood? Here 455 and 42 are the positive integers A and B, and this is the HCF of 455 and 42 is the largest integer D. Here D is 7. 7 that divides both A and B. And is there any integer that divides both 65 and 6? No. If we do 5, but it only divides the 65 only, not 6. And if we write 6, it divides only the 6, not 65. So 7 is the only integer that divides both 455 and 42, right? So 7 is the HCF of 55 and 42. This is the usual method we studied in our lower classes. And using Euclid's division algorithm, how we can find the HCF of 455 and 42? How we can find out? Using Euclid's division algorithm. We know the answer is 7. But we have to find it out using Euclid's division algorithm, right? How to find 455 is equal to A is equal to BQ plus R form for 0 less than or equal to R less than B, right? So 455 is equal to 42 into, what will be the quotient? 42 into 10, it is 420, right? Which is less than 455. 42 into 11, what is the answer? 42 into 11, 1 2s are 2, 1 4s are 4, 1 2s are 2, 1 4s are 4, 2, 4 plus 2, 6, 462. And that 462 is greater than 455. It should be less than or equal to 455. So we can't write 42 into 11 because this number answer 462 is greater than 455. So what we can write? The lowest number 42 into 10, right? So 42 into 10 plus dash is equal to 455. How we can find out? 455 minus 42 into 10, it is 425, 3, right? So plus 35. Understood? So 455 can write it as 42 into 10 plus 35. We have to do it till the remainder becomes 0. Here the remainder is 35, not 0. This is the quotient. This is A and this is B. Okay, and now we have to proceed. We have to proceed in such a way that we have to take this B. 42 is equal to, now we have to consider this B and M. Now we have to find the HCF of 42 and 35. Understood? So 42 is equal to 35 into 35 into 1, 35. 35 into 2, it is 70, and that 70 is greater than 42. So we have to write 35 into 1. Why we don't write into 2? Because it is 70 and that is greater than 42. So 35 into 1, 35 plus 7. Right? Why? Because 35 into 1 it is 35 plus 7. 35 plus 7 it is LHS 42. Now is the remainder 0? No, it is 7. We have to make the remainder 0. Now we have to find out HCF of B and R. Here B is 35 and R is 7. So 35 and 7. 35 is equal to, how we can write? 7 into 5 is 35 plus 0. 7 into 5, 35 plus 0, it is 35. Here the remainder is 0. So the step we have reached, because we have to do till the remainder becomes 0, and here we have reached the remainder 0. So this is the step, and what is the HCF? HCF is the divisor. This is called the dividend and this is called the divisor. This is called the dividend and this is called the divisor. This is the quotient we know and this is the remainder. And the divisor, when the step reaches 0 as the remainder, then that divisor is called the HCF. So here HCF of 452, 455 and 42 is 7. We got using our normal method, right? So 7 as the remainder. Understood? Now we can define what is Euclid's division algorithm. I already told you it's a method to compute the HCF of two given positive integers, but write these steps in your notebook because this is very important. In the examination, the question may be like this: what is Euclid's division algorithm? Define the steps and using Euclid's division algorithm find the HCF of so and so. So in the examination they may ask what are the steps required to find the Euclid's division algorithm. So please write this in your notebook. So to obtain the HCF of two positive integers, say C and D instead of A and B, in our textbook they have written C and D. C and D or A and B or P and Q, anything, okay? So to obtain the HCF of two positive integers, say C and D with C greater than D, right? So far we have discussed two positive integers A and B with A greater than B. Likewise, here they said consider two positive integers C and D with C greater than D, okay? So, what is Euclid's division algorithm? To obtain the HCF of two positive integers, say C and D, with a C greater than D, follow the steps below. And there are 3 steps. Write it in your notebook. The first step is apply Euclid's division lemma to C and D. Apply Euclid's division lemma to C and D. Here, in the previous example, we have done HCF of 455 and 442. And here, 455 is C and 42 is D. So apply Euclid's division lemma to C and D. Euclid's division lemma is what? A is equal to or C is equal to DQ plus R. Or we can say that if it is A and B, A is equal to BQ plus R, right? So here we have taken instead of A and B, C and D. So apply Euclid's division lemma to C and D. So we find whole numbers Q and R such that C is equal to DQ plus R for 0 less than or equal to R less than D. That's what we have written here. C is equal to DQ plus R. And here Q is quotient and R is the remainder. This is the dividend and this is the divisor. And C should be greater than D. Understood? Now the second step is that if R is equal to 0, D is the HCF of C and D. Okay? If R is equal to 0, then D, that is divisor, is the HCF of C and D. But here R is not 0 in this stage, right? So we can go to the next sentence. If R is not equal to 0, apply the division lemma to D and R. Apply division lemma to D and R. So in this case, the remainder is not 0. So we apply division lemma to 42 and 35. That is D and R. Understood? So if R is equal to 0, then D is the HCF of C and D. If R is not equal to 0, apply the division lemma to D and R. So here we have applied division lemma to D and R. In this case also, the remainder is 7 is not equal to 0. Remainder is not 0. So what we have done? Again, we did division lemma. We applied division lemma to this one, 42 and, sorry, not 42 and 35 and 7. That is D and R. C is equal to DQ plus R. D and R. That is 35 is equal to 7 into 5 plus 0. Understood? So again, once again, apply Euclid's division lemma to C and D. So we find whole numbers Q and R such that C is equal to DQ plus R for 0 less than or equal to R less than D. Second step, if R is equal to 0, then it is simple. D is the HCF of C and D. But if R not equal to 0, what we have to do? Apply the division lemma to D and R, right? Step 3, continue the process till the remainder is 0. Continue the process till the remainder is 0. Then when we reach the remainder as 0, then the divisor at this stage will be the required HCF. What is the divisor? 7 is the divisor. So this divisor will be the required HCF of C and D. Understood? So to obtain the HCF of two positive integers, say C and D, with C greater than D, follow the steps below, and there are 3 steps in Euclid's division algorithm. Step 1, apply Euclid's division lemma. What is Euclid's division lemma? Given positive integers A and B, we have found whole numbers Q and R satisfying A is equal to BQ plus R. Instead of A and B, here they have taken C and D. So apply Euclid's division lemma to C and D. So we find whole numbers Q and R such that C is equal to DQ plus R for 0 less than or equal to R less than D. Second step, if R is equal to 0, then D is the HCF of C and D. If R is not equal to 0, apply the division lemma to D and R. Now step 3, continue the process till the remainder is 0. The divisor, when the remainder becomes 0, then the divisor at this stage will be the required HCF. So we found the HCF of 455 and 42. HCF of 455 and 42 is same as HCF of 42 and 35, right? Which is same as equal to HCF of 35 and 7. Understood? Simple. So write this into your notebook. This is very important. Euclid's division algorithm. These 3 steps. Now we can do some more examples regarding the HCF, to find the HCF using Euclid's division algorithm. This is the question, friends. Use Euclid's division algorithm to find the HCF of 4052 and 12576. So we can find this HCF of these numbers, okay? So how we can write? First we have to take the largest number, right? So 12576, step 1, right? What is step number 1? Apply Euclid's division lemma to these two numbers. With this number should be greater than, this dividend should be greater than divisor, right? So 4052 into dash plus dash. What is quotient and what is remainder? We have to find it out. So 4052 into 1, it is 4052. 4052 into 2, what it is? 41810, right? 40, how to check it? 2 2s are 4, 10 remainder 1, 48104. And what about 4052 into 3? 4052 into 3, 3 2s are 6, 15 remainder 1, 4 3s are 12, 1 2 1 5 6. What about 4052 into 4? 4052 into 4, 4 2s are 8, 5 4s are 20, remainder 2, 4 4s are 16, 16208. Now consider this number. This Q should be less than or equal to 12576. We cannot write 4052 into 4 because it is 16208 and that is greater than this one. So we have to find a number which should be less than or equal to 12576. So what is the number? 12156, right? So we can write 4052 into 3 plus dash. How to find out? 4052 into 3, the answer is 12156. That means 12576 minus 12156 is the remainder 0, 2, 4. 420, right? So instead of remainder, what we can write? 420. Understood? How we got this? Okay. So 12576 is equal to 4052 into 3 plus 420. Understood? Now, is the remainder 0 in this step? No, because the remainder is 420 and that is not equal to 0. This is C, this is D, this is Q, this is R. We have to apply Euclid's division lemma, that is C is equal to DQ plus R for 0 less than or equal to R less than B, right? That is D. Now we have to apply step number 2. If R is equal to 0, then this is the remainder. But R is not equal to 0, then apply Euclid's division lemma to D and R. That is 4052 and 420. How we can write? 4052 and 420, right? Apply Euclid's division lemma to D and R. Now 4052 is equal to 420 into, we have to find Q and R, right? Dash plus dash, Q and R we have to find it out. Again doing the same step, 420 into 1 it is 420. 420 into 2 is equal to 048, right? How we got that? 420 into 2, 0, 2 2s are 4, 4 2s are 8. Now 420 into 3, what is the answer? 06160, right? 420 into 3, 0 6 1260. Then 420 into, okay, likewise 420 into 10, it is 4200. So 10 is not the answer. You have to check the numbers below 10. 420 into 9, what is the answer? Okay, we can apply 420 into 9 by, I will tell you, 0, 18, remainder 1, 36, 3780. Okay. See, when we do 420 into 1, 420 into 2, 420 into 3, likewise up to 420 into 10. When we do 420 into 10, it is 4200. That is greater than this one. We have to find a number which should be less than or equal to 4052, right? So, into 10 it is 4200. Then we have to find a number which is less than 10, right? So, 420 into 9, it is 3780. That is less than 4052, right? So, we can apply into 9, right? So, 420 into 9. Plus what is the remainder? 420 into 9, it is 3780, right? 3780. So what is the number here? How we can find it out? 4052 minus 3780. 2, 7, 9 minus 7 it is 2. Then here it is 0. 2 plus 0, 2. 8 plus 1, 15, remainder 1. 7 plus 2, 9. Plus that remainder 10. Then here it is 0 plus 3. Then that remainder 4. Okay. So here we can write 272. Understood? So 4052 is equal to 420 into 9 plus 272. Next step, is the remainder 0? No, the remainder is 272. So we have to apply division lemma till it reaches 0, right? Apply Euclid's division lemma to D and R. That is 420 is equal to 272 into dash plus dash. What is Q and R? Again, 270 into 1 it is 272. 272 into 2 it is 414. Reminder 1. 544. 544 it is greater than 420. So find a number which should be less than or equal to 420, and that is 272 itself. So we can write 420 is equal to 272 into 1 plus, what is that remainder here? 420 minus 272, right? 8, 4, 148. So here we can write 148. Did you get it? 272 into 2 it is 544. That is greater than 420. So you have to find a number which should be less than 420, less than or equal to 420. And that is 272 into 1 itself plus 148. We will get 420. Now in this step, is the remainder 0? No, the remainder is 148, which is not equal to 0. So you have to apply Euclid's division lemma to D and R. This is D and this is R, right? So 272 is equal to 148 into dash plus dash. What is quotient and remainder here? Here once again 142 into 1 it is 148. 148 into 2 it is 16, 9, 296. That is greater than 272. So you have to find a number which is less than 272, and that is 148. So into 1 plus, what is the remainder here? 272 minus 148. 4, 2, 1, right? So plus 24. Understood? Here it is 124, not 24, 124, okay? Now again, is the remainder 0 here? No. The remainder is 124, so you have to apply Euclid's division lemma again to this D and R. That is 148 is equal to 124 into dash plus dash. Again, 124 into 1 it is 124. 124 into 2, it's a bit lengthy guys, right? 248, and 248 is greater than 148. So you have to apply this number only, 124 into 1 plus dash. 148 minus 124, what is the answer? 4, 224. So you can write 24 here, because when we do 124 plus 24 it is 148. So is the remainder 0 here? No, the remainder is 24, right? So next step, apply Euclid's division lemma again to D and R. So 124 is equal to 24 into dash plus dash. How we can find out? 24 into 1, 24. 24 into 2, it is 48, right? 24 into 3, 72. 24 into 4, 96, right? 24 into 5, it is 120, right? 24 into 6, it is 144, right? Can we write 144 here? No, because it is greater than 124. So what is the number? 120, this one, right? So how we can write? 24 into 5 plus 24 into 5, it is 120, right? So 124 minus 120. What is the answer? 4 plus 4. Got it? So is the remainder 0? No. So you have to apply Euclid's division lemma to 24 and 4. So 24 is equal to 4 into 6. 4 into 6, it is 24 plus 0. In this step, we reached the remainder 0. So we can stop because we can't proceed further. Understood? So what is the HCF? HCF is the divisor here. The divisor at this stage is the HCF. And what is the HCF? 4. So we can write HCF of 4052 and 12576 is 4. That is HCF of 4052 and 12576 is equal to 4. Got it? It's a bit lengthy process, right? For some numbers like this. But the steps are simple The question is also simple. In the examination, they will not ask larger numbers like this, but you can expect these type of questions as well. Don't write these remarks because this is just for your understanding or just for your knowledge, not from the exam point of view. Euclid's division lemma and algorithm are closely interlinked, that we know. Although I told you that this Euclid's division algorithm is stated for only positive integers, but in some cases they can be extended for all integers except 0. That is, b cannot be equal to 0. This is just for your knowledge. Please don't write. This is not from the exam point of view. So friends, in this class we discussed these 5 points, right? First we discussed the difference between real numbers, natural numbers, whole numbers, rational numbers and irrational numbers. Then we defined the difference between the Euclid's division algorithm and the fundamental theorem of arithmetic. What is Euclid's division algorithm? It is the divisibility of integers, while here this deals with the multiplication of two positive integers. Then this Euclid's division algorithm is used to calculate the HCF of two positive integers, and here it is used to find the decimal expansion when the decimal expansion of a rational number is terminating and when it is non-terminating, repeating, right? Then we get into the definition of lemma, difference between lemma and an algorithm. And this is not from the exam point of view, this lemma and algorithm definition, it is just for your knowledge. Then we discussed about Euclid's division lemma, and that is theorem 1.1 in our textbook. So study that, it is important, Euclid's division lemma and the steps of Euclid's division algorithm. So we discussed Euclid's division lemma and Euclid's division algorithm and their examples. Hope you understood these concepts, these terms very well. So that's all for today's class. In the next class, we will be discussing application of Euclid's division lemma or algorithm to find properties of numbers. I already told you that it is used to find the HCF of two positive integers, and this Euclid's division lemma or algorithm can also be used to find properties of numbers that we will discuss in the next class. And we have homework, okay? You do this homework. These questions are in your textbook, that is exercise 1.1 and page number 7. And the question is, use Euclid's division algorithm to find the HCF of 135 and 225. Hope you can see this. 196 and 38220, and third one 867 and 255. We can solve these in the next class. You try to work this out. Okay, revise these topics very well. This chapter is very easy. What all things you have studied, revise it daily, do the problems daily, work out the problems daily. You can get the previous year question papers from the market itself, because so many question banks are in the markets, they are available in the market. So collect it and revise it, work out daily. Okay friends, that's all for today's class. If you like the channel, support it by subscribing and sharing it with your friends who are preparing for 10th board exam. See you in the next class. Till then, have a good day and thank you.